Okay, we're in section 8.4. You can read through example 1. It's verifying the area of a circle. That's not something I'm going to test you on. So before I go to example 2, though, I want to give you the rules because the rules appear after example 2, and it would kind of be nice to have them before you do example 2. So if you're dealing with a problem that has a square root of a squared minus x squared in it, if you're looking at a right triangle, then this piece down here, this is theta, this is your a and this is your x. Because think about doing Pythagorean theorem on this, and you would get x squared plus this nastiness right here squared is a squared. So when I solved it, I would have a squared minus x squared inside, and the square root of that would give me the other leg. We're doing this from this situation. A squared plus b squared equals c squared. But if I solved it for a, actually I want to solve it for b because I don't want to confuse with the a that's already in the problem. B squared would be equal to c squared minus a squared, and so b would be equal to the square root of c squared minus a squared. So what we're doing is we're saying if you've got a square root with a minus sign in there, the first thing is your hypotenuse squared, and the second thing is the opposite leg squared. So it translates over to the triangle I have on the left side of the paper. If that's the case, we could figure out what x was equal to if we just did the sine of theta would be equal to what? Opposite of our hypotenuse is x over a, so I could say x is equal to a sine of theta. That would be the substitution I'm going to use when I see when it looks like that. If I have a triangle where I know the hypotenuse, and if you look at this, you should recognize this as the a and the x being the two legs. Here's my theta. So in this case, using the a and the x, that's the opposite and the adjacent, that would be tangent is x over a. So x would be equal to a tangent theta if you get one that has a square root of a squared plus x squared. And then finally, the last version is if you have the x squared minus the a squared. Now if I set this upright, this is the x, this is the a, and because x is the hypotenuse this time, because it goes in front of the minus sign, it looks like that. And so if I'm trying to use a trig function that only uses the x and the a, adjacent over hypotenuse, that would be cosine, but I want to use secant, it's reciprocal, because that would be x over a, and then x would be equal to a secant of theta. So, depending on what's going on, those are the numbers you're going to use. Now, a is a number and x is a variable. So if we now go to example 2, it says, find the integral of dx over 16 minus x squared to the 3/2. Okay, so 16 minus x squared is the form a squared minus x squared. And it's 3/2, so it does have a square root in it. So in this case, a would be 4 and x would be x. And so the substitution that we use when it's a squared minus x squared is the sine function. And so we say x is equal to 4 sine of theta, using that triangle. And so dx would be equal to 4 cosine of theta d theta. Now, to simplify this mess, let's just look at that 16 minus x squared. 16 minus x squared to the 3/2 would then become 16 minus 4 sine theta squared to the 3/2, which would then become 16 minus 16 sine squared of theta to the 3/2. But I could factor out a 16 and be left with a 1 minus sine squared, let's see, don't close that, sine squared of theta all of that to the 3/2. Okay, but 1 minus sine squared is cosine squared of theta, which then turns into, I'm going to write it like this because it's getting too weird. The square root would be 4 cosine theta, and then when you cube it, you get 64 cosine cubed theta. Okay, so back to my problem. dx is 4 cosine of theta d theta, and that whole nonsense on the bottom is 64 cosine cubed of theta d theta. I can reduce the 4 into 64 and have a 1 and a 16, pull it out in front, cancel a cosine, and have that, which then turns into a secant squared, its reciprocal function, and the integral of the secant is the tangent of theta plus c. Now the final step is we have to get this back in x's. So we go back to our triangle, and our triangle, let me draw it in here, that we were dealing with. This was theta, this was 4x, and this was the square root of 16 minus x squared. Tangent is opposite over adjacent, and so this is going to turn into 1, where did they write my answer down? So all I have to do is write this as 1/16. Tangent is opposite over adjacent, and then plus c. So now we're back in x's. So you're playing a little game here. You're going through the trig triangles, the right triangles, and then when you get done, you have to take it back out. Okay, that finishes example 2. Example 3 wants the arc length of a parabola. They want us to evaluate from 0 to 2, 1 plus 4x squared, and that is the arc length of the segment on the parabola y equals x squared from 0 to 2. So they gave us it already set up. We just have to solve it. So the first thing I want to do is I need this to be an x squared, not a 4x squared. So I'm going to change this to, I'm going to do it in 2 separate steps. I'm going to pull the 4 out. So I have 1/4 plus x squared in there. Then I'm going to pull the 4 out as a 2, square root of 1/4 plus x squared. And then I can look at that and say, oh, that means that a is a half to work this problem. I'm going to draw the little triangle. I think I'll draw it right here. In this case, I have the 2 legs, and so I set it up as not there. Set it up from over here. In this case, A is 1, and B, and X, or U, whatever letter you want to use here, its square root is 2x. I'm not going to put a letter. So my triangle is going to have a 1 here, a 2x there, and a square root of 1 plus 4x squared. Here's theta. And then I did this little step. I should have made a triangle before I did my second 2 steps here, but we're good. So now this represents the plus version, and the plus version means I have the 2 legs, and so that's going to be the secant, or my tangent. So I'm going to use my substitution of, it is going to be a half. X equals, not u, sorry, x equals 1/2 tangent of u. I'm getting that from my triangle at the top of the page, the second triangle. X is equal to 1/2 square root of the 1/4 tangent of theta, which means that du is going to be, derivative of the tangent is the secant squared. Okay, so if I'm setting this nonsense up, this is going to end up being, let me just clean up, no equal sign, let me just clean up this mess. The 1/4 plus x squared. We're going to turn that into it's 1/2 squared plus 1/2 tangent of theta squared. Now if I pull out the 1/2, I get 1 plus tangent of theta, 1 squared plus tangent squared of theta, and the square root of 1/2, it's a 1/4. Square root of 1/4 is the 1/2 outside, square root of 1 plus tangent squared of theta. But this little piece right here turns into secant squared of theta, so this becomes 1/2 secant of theta, because the square root of something squared is just something. So this whole square root piece that we're working with is this guy right here. That's what we just worked out. And so this problem turns into 2 integral from 0, not 0 to 2, because I'm changing the variables. I have a 1/2 secant of theta, and then dx was 1/2 secant squared of theta d theta. So those two 1/2s, that's a quarter, but there's a 2 on the outside, so it turns into 1/2 the integral secant cubed of theta. And then we have to use reduction formula 4, which I wrote in the previous section. And it turns out that we have, let me get reduction formula 4, which remember you might want to put some of these on your note card for your test. But in the end, after you do the reduction on it, you end up with a 1/4 out here, a secant, and then a tangent, and then of course the natural log. We did one just like this in the previous section. Now, I have to go back and put back what it was. So I'm looking at my triangle up there, and it's 1/4. Secant is the flip of cosine, adjacent over hypotenuse. So hypotenuse over adjacent, which is just 1 plus 4x in a square root. And then tangent, which is opposite over adjacent, that would just be 2x. Oops, no, close it. Plus natural log, again, secant, plus tangent. And the whole nonsense is evaluated from 0 to 2. So we end up with 1/4. Sticking in a 2, we get 16 square root of 17, O times 4. I'll put it like that. And then we get plus the natural log of square root of 17 plus 4. And then we're subtracting the zeros. But since you're multiplying, that first term turns out to be a 0. And then here, put a 0 in that square root, and you get square root of 1 is 1, plus 2 times 0 is 0. So natural log of 1 is still 0, so that takes care of that. So now I'm going to go to my calculator, and I get a decimal version for this, 4.65. I could have cleaned this up a little more and written it as 1/4 4 square root of 17 plus natural log square root of 17 plus 4. I could have even gotten rid of the 4 and the 1/4 in the first piece. But nevertheless, it's still 4.65. That was a really bad one.